All right, good morning, guys and gals. This is the moment you've all been waiting for. We're going to be working on reducing, and we only do this when we're multiplying fractions. So it's a real great shortcut. Now it looks new, it looks difficult, but that's what we're going to find with most of our stuff. It just looks difficult. Once you get into the swing of things, you'll be able to do it effectively, and you will start to see why it is a great time saver and a great way to reduce small errors. Sometimes you put that notion up that it's too hard and it's pointless to do just as an excuse so you don't want to try it. But I want you to keep an open mind. We're going to practice it a lot today. We're going to go really slow. If it takes a couple days, it takes a couple days. And I want you to see if you can become comfortable using this. Anyhow, for the note, the purpose of cross reducing is to put it into its lowest terms. So before you even start to multiply it all out, we reduce it right in the question, and that makes when you get to an end answer, you don't have to reduce the lowest terms. And while you're doing larger questions, it makes the numbers you're using easier. Now, if you do this properly, like I said before, it will become a real time saver, and it will reduce small errors that you'll continually lose little half marks, or even bigger errors when you start multiplying things incorrectly and you get the entire question wrong. And that's going to come into play when we start doing larger questions, order of operation questions, when you start solving larger algebraic equations with fractions in them. There's lots of places to make small errors. So anyhow, now the trick of doing this in order to reduce, the trick of it is you just take one numerator and one denominator. You pick one in the top and one in the bottom that has some common factors. So you find a number on the top and a number on the bottom that 2 will both go into, or 3 or 5 or whatever the number is. They don't have to be on top of each other. Some people thought they have to be right above each other in order to reduce, and they can be, but they can also be across from each other. Again, it only has to be one from the top and one from the bottom. So one thing might happen, you might find today, is you might reduce a question and then still see that that number can be reduced somewhere else again. And it is okay to have a set of numbers that you reduce twice, because maybe 2 went into 4, but that leaves a 2 on the bottom, and then it will go into another numerator somewhere else. You can walk through this until you get to the point where it's in lowest terms. So don't panic if you reduce it one time and then you can use it again somewhere else. Anyhow, here are 4 examples to get us started. Example 1 is 3/5 times 10 over 12. And I'm going to switch colors because I think that'll be more effective if I switch my colors here. All right. Now, remember I got to find one from the top and one from the bottom. Well, 3 and 5 are not factors of each other. I know that, so I'm going to have to go somewhere else. And right off the bat, I see, 5 and 10, and I know 5 goes into 10. And here's how you say this to yourself. 5 will go into itself once. You cross it out neatly, and you neatly put a 1. As you say it, you do it. So 5 will go into itself once. 5 will go into 10 2 times. Now you have a choice. You could use 3 and 12 or 2 and 12, because remember I said you may find factors that once you've reduced, you can reduce again. But in my case, I'm going to go 3 and 12, because I know 3 goes into itself 1 time, and 3 will go into 12 4 times. So it's all still pretty neat, and what this really means now is 1 over 1 times 2 over 4. And you could do that, but if you look at it, you still have 2 and 4. You still have a numerator and denominator that can go into each other even further. So 2 goes into itself 1 time, 2 goes into 4 twice. Now when you look at it, there's nothing else to reduce. There's no top number and bottom number that you can take any further. So it's 1 times 1 is 1 across the top, and 1 times 2 on the bottom. And there's your answer. Let's go look at example number 2. Again, you're looking for common factors. They may be right above each other. They may be across diagonally, but never numerator to numerator. It always has to be one numerator and one denominator. I'm looking at it and I see that 5 will go into itself once and 5 will go into 15 3 times. 4 goes into itself once and 4 goes into 12 3 times. I see the two 3's, but they're beside each other. They're both denominators. I can't do that. I can't use that. So I have reduced mine as much as it's going to be. I multiply my two numerators. 1 times 1 is 1. I multiply my two denominators. 3 times 3 is 9. There's my answer in lowest terms. Now you're going to start to get questions that are even bigger, and you'll get 3 multiplication or 4, and it doesn't matter. And in fact, later on, for those people that want to challenge, you'll have bigger and more factors to look for. But 3 of them is just the same process as 2. You look for a common factor in a numerator and a denominator. So looking across here, and there are different ways to solve. So if you and your buddy were to put yours side by side, you may have chosen different factors for a top and bottom, but your answer will be identical when you get to the end. So I like 5s and 10s because I know for me they're very quick and easy. 5 goes into itself once, 5 goes into 10 twice. It's really important that you make this neat. You take the time and care to cross it out and then neatly put the new number. When you scribble and scratch, you start to lose focus of what you're doing. Anyhow, now I got 12 and 3, 4 and 8. I got a 2. I got to pick a number on the top and a number on the bottom. I'm going to go with 4 and 8 because I know 4 times 2 is 8. So 4 goes into itself once, 4 goes into 8 2 times. If I'm looking around, I see really easily 2 and 2 right over on the far right. 2 goes into itself once, 2 goes into itself once. And now all I'm left is 12 and 3. Hopefully that you know 3 goes into 12, so 3 goes into itself once, 3 goes into there 4 times. When you look across, there's nothing left to reduce. I really have 4 times 1 times 1, and that's 4. And on the bottom I have 1 times 1 times 1, and that's 1. So 4 over 1, or 4, is my answer there. In my last example, you might get it set up like this, because these are closer to the questions that we're going to get this year. Some improper or mixed fractions, you got to change to improper, all that sort of stuff first. So let's, before we even begin to think about reducing, get this into a multiplication question, because remember, cross-reducing only works with multiplication. So 4 1/2, we should know by now, is 9 over 2, divided by 3 over 8. In order to do division, that really becomes a multiplication question, and 3/8 gets turned upside down, it becomes its reciprocal. And now we're looking at that. Now that we're looking at this question properly, you can see that there are opportunities to reduce. So 3 will go into itself once, 3 will go into 9 3 times, 2 will go into itself once, 2 will go into 8 4 times. If I look across my question, there's no other place where a number from the top and a number from the bottom have a common factor, so I'm done. This will simply be 3 times 4 is 12, and the bottom is 1 times 1 is 1. So 12 over 1 is your answer, and we know that 12 over 1 is just 12 as a whole number. This takes practice and an open mind that it's new, but you will find, many of you, with a little bit of practice and a few deep breaths, that this isn't as hard as you first thought. Go ahead and practice it. We have a couple days to do it. Thank you.